All right, so here we're going to evaluate the definite integral of, and now I'm going to make it the cubed root of 1 plus 7x times dx. All right, so this looks a little bit intimidating, but we're just going to go ahead and do some u substitution, right? So let's set our u to whatever's underneath this radical. So if we go ahead and set that, we will have u is equal to 1 plus 7x. That way we can go ahead and substitute that later once we get everything in terms of u. Now let's go ahead and differentiate both sides of the equation with respect to x. So on the left side we get du is equal to 7 dx. And if we want to replace dx, we simply isolate it. I'll draw an arrow here. We isolate dx and we divide both sides by 7. We get dx to being du over 7 here. All right, so let's go ahead and change everything in terms of x now. So let's go ahead and replace 1 plus 7x to u. And to the cubed root, I'm going to go ahead and just say that this is u to the 1/3 power. That's the same thing as writing a cubed root. And dx is equal to du over 7. So du over 7. All right. Now, here's a tricky question. What are our bounds in this integral? Is it from 0 to 1? No, it's not actually. Because from 0 to 1, this is corresponding to our variable we have in terms of x, but now we've changed everything in terms of u. So that means our bounds are changed as well, because our bounds are going to be with respect to our variable u here. So how can we do that? Well, remember these bounds are ranging from x, right? So we need them to range from u. How can we do that? Well, we can use this equation to find where u is ranging from by substituting x with whatever our ranges are. So when we assume x is equal to 0, our lower limit right here, we'll have 1 plus 7 times 0. I just replaced x with 0 and we made the case x equals 0. So the lower bound here is going to be 1. Now what about when x equals 1, our upper bound? So if we put this, use this equation, we get 1 plus 7 times 1, and u therefore is equal to 8. Okay. Let's go ahead and now change these limits. So now we have it in terms of u. We can go ahead and put our lower limit, which is u equals 1, and our upper limit, which is u equals 8. All right. So now that we have done that, let's go ahead and evaluate the definite integral with respect to u. So integrating a polynomial here, and I can go ahead and take out this constant 1/7. So I'll go ahead and put the 1/7 out here. What's the integral of u to the 1/3? Well, we just add 1 to the exponent, so it's u to the 4/3 divided by our new exponent. So we divide by 4/3, or we can multiply by our reciprocal, which is 3/4. And we're evaluating this from 1 to 8. All right, let's go ahead and do that. So I'm going to go ahead. I can also pull out this constant 3/4 here. So I'm going to say if we pull out this constant here, we'll multiply this fraction by this fraction. And so we should get 3 over 28 to the u, or times u to the 4/3, ranging from 1 to 8. All right, let's go ahead and evaluate this from 1 to 8. So we start with our upper bound. And by starting with our upper bound, we plug in 8 for u. So 8, and I'm going to go ahead and say for this exponent, it's going to be to the cubed root of 8, because this might be a little bit more clear, to the 4th power, minus 1 to the 4/3 power. Now, why I say it's going to be a little bit more clear if I put the cubed root here, well, we know what the cubed root is. It's actually an integer. It's going to be, well, we know that 2 cubed is 8. So taking the cube root of that should give us 2. So the cubed root of 8 is 2, therefore. So let's go ahead. 3/28 times 2 to the 4th. So now this is 2 to the 4th power. So 2 to the 4th power is 16 minus 1. 1 to the 4th power is just going to be 1. All right, so if this, we'll go ahead and do this operation here, it should be 15. So 15, therefore, times 3/28. So that should end us up with 45/28 as our answer. That's the area under the curve of this equation from 0 to 1. All right, well, that's one way of doing this if we had it in terms of u. What if we wanted to substitute back in x? So let's see. If I go ahead and, well, no, let me keep this out here. So if I go ahead, what if I keep this part right here? We evaluated the integral. So what if instead I substituted back in x? So we have 3/28. So let's replace u with 1 plus 7x. So u, we're replacing that with what we substituted earlier. So we're just doing a back substitution here. So 1 plus 7x to the 4/3. And now we can change our limits back to what we had earlier from the problem statement. So 0 to 1, because now we substituted u back into x. So now our limits are back in terms corresponding with x here. All right, let's go ahead and evaluate this. And let me draw kind of it like this so we can have room to evaluate this. All right, so how do we do this? So we can still have our fraction out here. Now when x is equal to 1, it's going to be 1 plus 7. So that's 8 to the 4/3. Minus, if we plug in 0 here, it's going to be 1 plus 0. So 1 to the 4/3. And we can see clearly that we're ending up with the same result here. It's just going to be, if we evaluate this, remember 8 to the 4/3 is 2, as we had said earlier. And then, or sorry, 8 to the 4/3 is actually 16, but 8 to the 1/3 power is 2. And then 2 to the 4th power is 16. Minus 1 to the 4th power, that's 15. So if we go ahead and say that, I'll write this step here. So 3 times 15/28. And we end up getting the same thing here. So what does this tell us? This says when you evaluate a definite integral with bounds and you use U-substitution, you can either change the bounds. It's your call. You can either use bounds in terms of u, or you can back substitute and use the original bounds in whatever variable you had. In this case, we had our variable in x, and you should get the same result. Now, if you're not sure if you did your integration and you evaluated correctly, try doing a substitution of the other variable and use those bounds with respect to that variable and see if you get the same thing. And if you get the same thing, then you know that's checking your work. So you definitely did it right.